Many people think that when an O2 sensor shows a warning code, it must be replaced immediately. But the truth is, in many cases, the sensor is not broken. It's just dirty and contaminated by carbon, oil vapor, and unstable exhaust gases from daily driving. Short trips, ethanol fuel, city traffic, and long service intervals slowly make the combustion and exhaust system dirty. When this happens, the oxygen sensor becomes slow, fuel economy drops, and engine performance starts to feel unstable. The good news is, you don't always need to remove or replace the sensor. With proper maintenance and system cleaning, the O2 sensor can often return to normal performance. In this video, we will go through 8 practical tricks to clean and maintain your O2 sensor without removing it. Starting from the safest method and moving step by step to deeper system cleaning techniques that help restore clean exhaust flow and stable engine performance. Number 1. The fuel additive scrub. When most people see an oxygen sensor code, they immediately think the sensor is bad and needs replacement. But in many cases, the sensor is not damaged. It's simply contaminated by carbon deposits from years of combustion. Over time, modern gasoline, especially ethanol-blended fuel, leaves residue inside the fuel system and combustion chamber. This residue eventually travels through the exhaust and coats the oxygen sensor tip, causing it to respond slower and send inaccurate readings to the engine control module. One of the safest and easiest ways to reduce this contamination is by using a high-quality fuel system cleaner. Fuel additives, such as PEA-based cleaners, work by mixing with gasoline and flowing through the entire fuel system. As the engine runs, the cleaner removes carbon buildup from injectors, intake valves, and the combustion chamber, which leads to cleaner combustion and cleaner exhaust gases. Cleaner exhaust means less contamination reaching the oxygen sensor, allowing it to respond more accurately over time. To apply this method, pour 1 bottle of fuel system cleaner into a nearly empty fuel tank, then fill it with fresh gasoline and drive normally through a full tank cycle. For better results, repeat the process in the next fuel cycle to gradually remove deeper carbon deposits. This method works slowly, but it is very safe because it cleans the entire system without putting stress on engine components or the catalytic converter. If you want a faster and more direct cleaning method, the next technique sends cleaner straight into the intake system for deeper decarbonization. Number 2. The vacuum line induction method. If fuel additives feel too slow, this method delivers the cleaner directly into the engine for faster results. Instead of waiting for the chemical to move through the fuel system, the vacuum line induction method sends intake cleaner straight into the intake manifold, allowing carbon deposits inside the combustion chamber and exhaust system to break down more quickly. As these deposits burn off, exhaust gases become cleaner and more stable, which helps the oxygen sensor respond more accurately. To perform this method, start by warming up the engine to normal operating temperature. Locate a vacuum line connected to the intake manifold, such as the brake booster vacuum line. With the engine running at around 1,500 to 2,000 RPM, slowly introduce a sensor-safe intake cleaner in small amounts and allow the engine to draw it in gradually. White smoke from the exhaust is normal because it indicates carbon and residue are being burned and expelled. This method requires caution. Introducing too much cleaner too quickly can stall the engine or overload the catalytic converter, so the chemical must be applied slowly and in controlled amounts. Compared to fuel additives, this method is faster and more aggressive, making it useful when the oxygen sensor response is already slowing down and fuel economy has started to decrease. If you prefer a completely chemical-free approach, the next method uses engine heat and high RPM to burn carbon naturally. Number 3. The Italian tune-up. If you prefer a completely chemical-free way to clean your oxygen sensor, the Italian tune-up is one of the simplest methods mechanics have used for years. Many engines develop carbon buildup not because of faulty parts, but because they are driven too gently for long periods. Short trips, low RPM driving, and constant city traffic prevent the engine from reaching proper operating temperature, which allows carbon deposits to accumulate and contaminate exhaust gases over time. The Italian tune-up uses heat and engine load to burn off these deposits naturally. When the engine runs at higher RPM, combustion becomes hotter and more complete, helping remove carbon from the combustion chamber and exhaust system. As exhaust gases become cleaner and more stable, the oxygen sensor is exposed to cleaner flow and can respond more accurately. To perform this method safely, make sure the engine is fully warmed up. Then drive on an open rotor highway and maintain around 3,000 to 4,000 RPM for about 10 to 15 minutes. This allows the exhaust system and oxygen sensor to operate at optimal temperature while gradually reducing light carbon buildup. Avoid aggressive acceleration on a cold engine or holding extremely high RPM for too long. The goal is steady and controlled high-temperature operation, not harsh driving. This method works especially well for vehicles that are mostly used in city traffic and rarely reach highway speeds. If heat alone is not enough to remove deeper carbon deposits, the next method uses controlled steam cleaning to remove buildup more aggressively. Number 4. Water mist steam cleaning. If carbon buildup is too heavy for heat alone to remove, water mist steam cleaning can provide a deeper cleaning effect for the oxygen sensor and combustion system. This method uses a fine mist of water introduced into the intake, which turns into steam inside the combustion chamber and helps break down stubborn carbon deposits that contaminate exhaust gases and slow oxygen sensor response. When a small amount of water enters a hot combustion chamber, it quickly turns into steam and helps loosen carbon on piston crowns, intake valves, and exhaust passages. As these deposits break apart and burn off, exhaust gases become cleaner and more stable, allowing the oxygen sensor to operate with better accuracy. To perform this method safely, the engine must be fully warmed up and running at around 1,500 to 2,000 RPM. Using a spray bottle, introduce a very fine mist of water into the intake or throttle body in small and controlled amounts, while the engine continues running smoothly. Light white steam from the exhaust is normal and indicates the cleaning process is working. This method requires extra caution. Spraying too much water at once can cause engine misfire or even hydrolock, which can seriously damage internal components. The key is to use only a fine mist and allow the engine to process the steam gradually. This technique is usually applied when carbon buildup is moderate, and previous methods have not fully restored oxygen sensor performance. If the issue is not carbon but incorrect airflow readings affecting the oxygen sensor, the next method focuses on restoring airflow accuracy through the MAF sensor. Number 5. MAF Calibration Reset. Sometimes the oxygen sensor is not dirty or damaged at all. It only appears to malfunction because the airflow data entering the engine is incorrect. This is where a MAF calibration reset becomes important. When the mass airflow sensor becomes contaminated by dust, oil vapor, or debris, it sends inaccurate airflow readings to the engine control module. This causes an improper air-fuel mixture, leading to unstable combustion and inconsistent exhaust gases, which can make the oxygen sensor appear slow or faulty. The concept is simple. The oxygen sensor relies on a stable air-fuel mixture to produce accurate signals. By cleaning and recalibrating the MAF sensor, airflow data becomes accurate again, combustion stabilizes, and the oxygen sensor can return to normal operation without being replaced. To perform this method, turn off the engine and locate the mass airflow sensor on the intake air duct. Carefully remove it and spray it with a dedicated MAF sensor cleaner, avoiding any physical contact with the sensing element. Allow the sensor to dry completely before reinstalling it. Then start the engine and let it idle for a few minutes so the engine control module can relearn the correct airflow data. This method is especially useful when oxygen sensor codes appear together with rough idle, poor fuel economy, or unstable engine performance. In many cases, restoring proper airflow balance allows the oxygen sensor to produce stable and accurate readings again. If oil vapor contamination is entering the intake system and affecting airflow and exhaust quality, the next method focuses on refreshing the PCV system to prevent oil residue from reaching the oxygen sensor and exhaust system. Number 6. PCV System Refresh. In some cases, oxygen sensor contamination is not caused by carbon, but by oil vapor entering the combustion system. This usually happens when the PCV system becomes clogged or worn out, allowing excessive oil vapor to flow into the intake and burn inside the engine. Over time, this creates dirty exhaust gases that coat the oxygen sensor and slow down its response. The solution is to refresh the PCV system and restore proper crankcase ventilation. A properly functioning PCV valve controls the flow of crankcase gases and prevents excessive oil from entering the intake system. This leads to cleaner combustion, more stable exhaust gases, and reduced oil contamination on the oxygen sensor. To perform this method, locate the PCV valve on the valve cover or intake hose and inspect it for oil buildup or blockage. If the valve is clogged or worn, replace it with a new one and check the PCV hose for cracks or restrictions. After installation, start the engine and let it idle for a few minutes so the ventilation system can stabilize and reduce oil vapor contamination. This method is especially useful for high-mileage engines that show signs of oil consumption, rough idle, or recurring oxygen sensor codes caused by oil-contaminated exhaust gases. Restoring proper PCV function helps the engine produce cleaner exhaust and protects the oxygen sensor during normal driving. If heavy carbon deposits still remain inside the intake and combustion system, the next method uses a controlled intake drip cleaning process for deeper decarbonization. Number 7. Intake drip kit. When carbon buildup becomes too heavy for fuel additives, vacuum induction, or steam cleaning to handle, a more controlled decarbonization process is needed. This is where an intake drip kit is commonly used, especially in professional workshops. Unlike vacuum line induction, which introduces cleaner manually, an intake drip kit delivers a steady and controlled flow of cleaner into the engine. This controlled process allows deeper carbon deposits to be removed safely while protecting sensitive components like the oxygen sensor and catalytic converter. The system works by slowly feeding a specialized intake cleaner into the intake manifold while the engine is running at a stable RPM. Because the flow is regulated, the cleaner enters the combustion chamber gradually and breaks down stubborn carbon deposits on intake valves, piston crowns, and exhaust passages. As combustion becomes cleaner and exhaust gases stabilize, the oxygen sensor is exposed to cleaner flow and can produce more accurate readings. To perform this method, the engine is warmed up and connected to an intake drip cleaning kit through a vacuum line or intake port. The cleaner is then delivered slowly while the engine runs at a steady RPM, allowing deep carbon deposits to be removed over time. Light smoke from the exhaust is normal and indicates that carbon and residue are being burned and expelled. This method requires proper control and equipment because excessive cleaner or incorrect flow can overload the catalytic converter or cause unstable engine operation. For this reason, intake drip cleaning is often performed under controlled conditions or with professional tools to ensure safe and effective decarbonization. This method is especially effective for high-mileage engines with heavy carbon buildup that continues to affect oxygen sensor performance after basic cleaning methods. If the oxygen sensor issue is not caused by carbon or oil contamination but by exhaust system problems, the final method focuses on checking hidden exhaust leaks that can disrupt oxygen sensor readings. Number 8. Exhaust system leak check. Hidden cause of O2 sensor contamination. Sometimes the oxygen sensor is not dirty at all, and no cleaning method will solve the problem. The real issue can come from hidden exhaust system leaks that allow outside air to enter the exhaust stream and confuse the oxygen sensor. The concept is simple. The oxygen sensor measures oxygen content in exhaust gases to maintain the correct air-fuel ratio. If there is a small leak in the exhaust manifold, gasket, or pipe before the sensor, outside air enters the system and dilutes the exhaust gases. This creates unstable readings, triggers fault codes, and makes the sensor appear faulty even though it is still working properly. To check for this issue, inspect the exhaust manifold, gaskets, and pipes for ticking sounds, black soot marks, or unusual exhaust noise. A smoke test or careful visual inspection can help locate small leaks that are not immediately visible. Once the leak is repaired, exhaust flow becomes stable again, allowing the oxygen sensor to receive accurate readings and return to normal operation. This method is important because many oxygen sensor problems are actually caused by exhaust leaks, not contamination. Fixing the leak restores proper exhaust flow, prevents false sensor readings, and protects the oxygen sensor from unnecessary replacement. By understanding these 8 maintenance tricks, you can restore oxygen sensor performance without removing it, reduce repair costs, and avoid replacing parts that are still functioning properly. At the end of the day, cleaning or restoring an oxygen sensor without removing it is not about using one magic trick, but about understanding what actually causes the sensor to become slow or contaminated in the first place. Carbon buildup, oil vapor, incorrect airflow, heavy deposits inside the combustion chamber, and even hidden exhaust leaks can all affect how the oxygen sensor reads exhaust gases and sends signals to the engine control module. That is why these 8 methods work as a complete system approach. Fuel additives slowly clean the entire fuel system. Vacuum line induction delivers faster chemical cleaning, and the Italian tune-up uses heat to burn carbon naturally. Water mist steam cleaning helps remove stubborn deposits, while MAF Calibration Reset restores proper airflow readings so the oxygen sensor can operate accurately again. PCV System Refresh prevents oil contamination. Intake drip kits handle heavy carbon buildup in a controlled way. And exhaust system leak checks ensure the sensor receives stable and accurate exhaust flow. When these methods are applied correctly and patiently, many oxygen sensor problems can be reduced or even resolved without removing the sensor or replacing expensive components. This not only saves repair costs, but also helps extend the life of the catalytic converter, improve fuel economy, and keep the engine running smoothly. The key is to start with the safest and simplest method, then move step by step to more advanced techniques only if needed. In many cases, the oxygen sensor is not actually broken. It just needs cleaner combustion, stable airflow, and proper exhaust conditions to work normally again. With the right approach, you can restore oxygen sensor performance, avoid unnecessary replacements, and keep your engine efficient for the long run.